function.
Did you not get into it?
Nope.
Oh, I'm all looking through my paper. So you're wait, functions.
Yeah, I gave it to you. No, I didn't give it to you, no.
So I think I give you the chapter 3, 4.3.
Okay.
Just quickly yesterday.
Okay. Let me make a note. So yeah, if there's anything else looking not quite right, that is one of the two reasons why I give you this grade sheet summary. Is the first reason obviously so you can see where you are, and the second reason is so I can make sure everything in my spreadsheet looks right. 4.3. Yeah, 4.3. Okay, I'll look for it. All right. I started you? I have. That was exciting. I'm so happy I got that. Did I do that?
Yes.
I did, okay. Okay. I'm so wild. It's crazy. Oh my gosh, Jeff, you're just so wild. So, we're about to, one thing I like about the way I've got it so that I break it up in chapter 4 is I want you to get really used to the basics of graphing, the idea behind slope, because the next thing we're going to do is we're going to put a lot of these things together. So you understand intercepts a little bit better now. You understand slope. You understand basics of graphing points and lines. So now we're going to talk about equation of lines. There's a couple of them we're going to look at this semester. One of them is the very basic one, and another one's a little bit bigger and funkier looking, but we'll look at it. So there's a couple ways I could do this. And one way I like to do this is by doing something we've already done and seeing how it relates to what we're about to do. So let's say we've got this here. Yep. So let's make a table of values. Can you guys take a minute and fill this in for me, for this equation? Yes. So, direction distance, that's 2. You can get it from there. That's with all the points also. But I mean, if you haven't corrected this yet, that's a huge one. Not that I've graded yet. There are a couple that I haven't graded yet, so you might be one of those. Yeah. But double check. Okay, let's see. Yes, ma'am.
On 3.1, I'm stuck on number 3 versus 2.
Wait. All right. So we're in the middle of this guy here, right? So you're right, though. I didn't really stop for homework questions. I was focused more on the test stuff. But hit me up after class. We should all be working on this guy. So if I put a 0 in there, what do you guys get? 5. And then if you put a 1 in there, you get negative 3 times 1 plus 5, negative 3 plus 5, 2. If you put a 2 in there, you get negative 3 times 2 plus 5, negative 6 plus 5, negative 1. And if you put a 3 in there, negative 8 times 3 plus 5, negative 9 plus 5, negative 4. Okay, now watch. So you guys are going to know exactly what the hell I'm doing right now. And the rest of us are going to catch up.
Yeah.
Let's talk about how this seems to move. So when you draw a line, you can definitely see it's moving, right? And I often talk about like we're on a trail, we're going somewhere. So if x changes by 1, if x goes up by 1, we all right?
Yes.
What does it look like the y's are doing? Do the y's increase or decrease?
Decrease.
By how much? 3. So it goes down 3. And again, let's check it. If I increase my x by 1, what's the y do in the meantime? Again, it goes down by, you guys see that? It goes down by how much? 3 again. And of course, if I increase that by 1, this happens. That goes down by 3. You guys with me? What's up? What's up?
It's a new one.
Say again.
It's a new, like,
A new idea.
new thing to.
Old idea, but we're building it together. All right. Do you guys understand? Even if you've never heard me say exactly this, but if I let the x change by 1, if the x goes up by 1, the y goes down by 3. If the x goes up by another 1, the y goes down by another 3. Yes? Do you guys see that?
Yes.
Don't think about where I'm going with it necessarily. Just you can see that, right? How we doing? You all right? Okay.
So it's always 1 for -3?
Yes. So every movement of 1 in the x direction, I seem to be moving 3 down in the y direction. Now, isn't that sound a lot like the idea of slope? Right? How much do I rise? Actually fall 3 while I run 1. Fall 3 while I run 1. Yes?
What about x, number 2x? What about this? It's about the -2. -2, I mean. Was gonna be positive, the same or different?
Are you asking if these will change?
Mm-hmm.
Nope. So here, since you asked, you guys don't have to write this down, but let me build this back. Give myself some more room. So let's go backwards in sign. If we put a -1 in, what do we get if we get a -1 in there? -3 times -1 is
Positive
3 plus 5, 8. So look, if I go up by 1 on my x, how much did the y's change?
3.
3. So I can make a prediction now. If this is -2, what would I predict this would be? 11. Right? Just seeing the pattern.
Yes.
Yes? And sure enough, if I put a -2 in, -3 times -2 is 6 plus 5 is 11. I like it. Is that cool?
Yes.
So, the slope here then would be what? The slope would be, how much do you go in the y direction? Down 3.
-3.
Over how much in the x direction? 1. So the slope is -3. What's the y-intercept? You can see it. Yes. Y-intercept is always the point. Oh, that's nice. Every math class needs a little musical interlude. The y-intercept is always a point where x is, what do you make x to find the y-intercept? X is 0. I like it. And that's the mistake a lot of you guys made, and not a lot, but too many. You found the x-intercept, you found the y-intercept, and then you made one point out of that. That doesn't make any sense. To solve for y, you must have plugged something in for x, and vice versa, right? So you can't plug in a 0 in for x and a 0 in for y, and then make one point out what else you get. They each are their own point. So when I plugged a 0 in for x, I got a 5 out for y. That's the y-intercept. So if that would have been a 6, what would have been here? 6, right? Because when you plug a 0 in, I'm going to get whatever number this is. That's why I got a 5, because there's a 5 there. So it looks like if y equals something x plus something, this second thing is going to be the y-intercept, the y piece of the y-intercept. Because how do you find the y-intercept? You make x 0. So whatever that number is, would be the y piece of the y-intercept. And also, negative 3 is the slope. Where do I see negative 3 in the equation? So right there, right? Maybe. So here's what's really cool. If x changes by 1, what does y do? It's negative 3 times that. So this number, I call it the amplifier. I might be kind of weird. It amplifies what x is doing. So if x changes by 1, y will change by this much times that. That's why I saw it changing by negative 3, because that's the multiple. That's every time x changes by 1, y is going to change by negative 3 times that. And everything starts off at 5. Maybe. Craziness. So what I am proclaiming then is that if I have a line in this form, that number is the slope, and that is the y piece of the y-intercept. Okay, so a lot of you guys, I don't know, some of you guys at least have seen that before, y equals mx plus b. So, let's do one more of these, I think, just to really do some more concrete stuff with this. Somebody give me a fraction.
3 over
6, 3 over
4.
4, okay. So let's do 3/4 x minus 2. So just to remind you guys, when you're constructing a table, you have control, not complete control, because you got to live within the equation, but so I'm definitely going to put 0 in. But would I put 1 in here if I wanted to be nice to myself? Shit, no. Well, what am I going to put in there? 4, because then the 4s we cancel and I get nice whole numbers, right? So we can be nice to ourselves when we're the ones picking what to throw into this thing. So I'm going to pick 4, and obviously I probably would pick negative 4, right? So let's see what we get. So if I put a negative 4 in there, 3/4 times negative 4 minus 2, what happens here?
Yes.
Yeah, the 4's cancel, so you get negative 3 minus 2, negative 5. You guys with me?
Yes.
What do you get when you put a 0 in? Please let that be easy.
Maybe.
Yeah. 3/4 times 0 goes away. Negative 2 is left. And when you put a 4 in there, 3/4 times 4 is really nice. 4's go away, I get 3 minus 2. I get 1. Now, let's check. If what I said earlier is true, that should be the slope, meaning if x changes by 4, y should change by 3.
Okay, 0, multiply 3 by 4 is going to be 0.
Yes.
Yeah, it's going to be number 2, the same number.
Yes. So that verifies this number is the y piece of the y-intercept. Right? Because if I made x 0 here, what do I get for y? B. Right? No matter, I don't give a shit what m is. If I make x 0, it's dead. So y would equal b. Okay, I like it. And look, if I go up by 4 on the x, what do I do with the y? What's the y's do? From negative 5 to negative 2, I went up 3. 3/4, bam. Okay, so I really want you to buy into this equation. Not just an equation we say, here it is, and there's not what you, no. It's an equation that exists because it makes sense. It does what it's supposed to do. I'm not going to identify those pieces of it. So what really kicks ass now is if somebody gives me an equation and it's not solved for y. So if I said find the slope in the y-intercept for what you got, Jeff? 5x minus 3y equals what, Jeff? I don't know.
73.
No! Man, you're mean. Shit. The quickest way to find the slope in the y-intercept is to solve for y, because then this almost seems too nice to believe, too nice to trust, but everything falls into place. And we see this throughout all of mathematics. We are not going to talk about this right now, but I just want to let you know this. If you set up the equation of a circle, that is going to be kind of a weird equation because I have to kind of make it curve back, right? But if you set it up in the right form, the center of the circle is in the equation and the radius of the circle. Those are the two most important things. Would you agree with me? You guys know circles, right? If I know where the middle is and what the radius is, I can graph it. Yes, maybe? Okay, I like it. So the equation will actually show you those things if you put it in the right form. So the line equation, if I put it in the right form, it'll tell me the most important things. That's kind of freaking cool. Right? There's a direct connection between what we see in an equation and what we actually see visually, physically. So how do I solve this for y?
Subtract 5x.
Sure. Subtract 5x. By the way, while I'm thinking about it, a few of you guys need to notice this. That negative sign can't just go away. It's there. So if I cancel this piece, that's still negative 3y. So a few of us had some mistakes because that negative somehow escaped. It like fell off the side of your paper or something, so there's negatives on the floor, so just be careful. And then of course, what do I do next?
Divide by 3.
Divide by
3. Negative 3.
negative 3. So there I get positive y equals positive, right? Positive 5/3 x
Negative 3.
minus 3. So what would the slope be?
5 over 3.
5 over 3. Why? Because it's in front of the x. What's the equation tell me? Whatever number's in front of the x is the slope, and whatever number's by itself is the y piece of the y-intercept. That kicks so much ass, right? If you get y by itself, everything falls into place. That's beautiful. And it happens, like I just told you, it actually happens a lot in math. Math is not always evil. It's trying to help you out sometimes. Sometimes it is evil. So let's do one more step. So you just identified for me the slope and the y-intercept. What's the y-intercept again?
0, negative 3.
Beautiful. Look at that shit. I love it. Don't tell me the y-intercept negative 3. That don't make any sense. The y-intercept is a point. And I make a big deal out of this to help you. Can you graph that?
Yes.
Okay, do it.
Point.
Graph it. So what's the slope tell you to do?
Right.
I know where to start, and I know where to go. That's why those two things together is all I need to make the line. So I just need a place to start. Zero, negative 3. And then where do I go from there?
Up 5.
Up 5. 1, 2, 3, 4, 5.
Over 3.
Over there. 1, 2, 3. What point did we just arrive at? 3, 2. How do I check to make sure my work is right? Plug what in? Where? And the equation it came from, right? So what should happen if I plug a 3 in for x and a 2 in for y? It should make that equation work. So sure enough, 5 times 3 is 15. Minus 3 times 2 is 6. 15 minus 6 is freaking 9. It works. Do you guys see that? Whenever I hit a new problem in mathematics, I'm always like, okay, how can I make sure that my answer is right? Is there a way I can do that? There isn't always a way you can do that. But here, you end up at another point. If it really is a point, it better work in the equation. Those two go together. If it works in the equation, it's a point on the line. If it's a point on the line, it works in the equation. Bam. I love that shit. What's that? Oh, it's okay. I'm used to that. It might be just me. Okay, so let me give you one to try on your own. So find the slope and the y-intercept for this. Oh, what you got, Jeff? Let's see. You can do it, dude. Can you? Yeah. It doesn't matter. You can do it. You can do it. Look at you go. All right. Apparently need a lot of motivation to get through making a problem. So find the slope and the y-intercept first, and then try to graph it like we did this. See if you're going to spam or something. I don't think I've gotten an email from you, huh? Oh, yeah, I know. I would realize if I got one. So, check my spam. Okay. I don't remember getting one, but we'll see. All right. So to find these, what do you have to do to that equation? You gotta get it solved for what? So to get that thing by itself, I subtract 8x. Oh my gosh. You have expired. Now, real quick, do you guys notice I'm being really nice to myself and I'm putting it in the right order? I put the negative ax first. You guys see that? You don't have to, but then it will match up with mx plus b. Okay. And then the last step on the solving is to divide by 3. I like it. So then what's the slope?
Negative 8 over 3.
And the y-intercept?
0, 5.
0, 5. Kick ass, right? Sweet. And now graph it if you haven't graphed it yet. Normally, if you use a scale of 1, I don't mind if you don't label it, but any other scale, you better label it so I know what the hell's going on. So 0 to 5, right there. And then from there I go
Down 8.
down 8, 5, 6, 7, 8, and then
Over 3.
over 3.
Yes, I got it.
Woohoo!
Yes.
And what point is that?
3
3,
negative.
-3. So to check it, 8 times 3, 24. 3 times -3, -9. 24 minus 9 is 15, check. It makes the equation work, which is why it is a point on the line. I like it. Yes?
Is it the 3, -3, your points?
Yes, 3, -3.
How did you get the 3 and the negative?
No, I can see it. 3, -3.
Yes.
Do you see that?
Oh,
What?
because your starting point was
No,
0,
yeah,
5.
because I did this, I got to a point, and then I can actually just see what point that is.
Yes.
Is the point 3, -3.
Yes.
Then I go check the algebra. Hey, algebra, you got the same shit I did? Yes, it works in there. Maybe. Okay.
So how would you count the 0, 5?
How do you mean count it?
Or graph it?
There it is.
Yeah, that's 0, then 5.
Yeah, 0, 5. And then this tells me to go rise 8, which really means fall 8, right? Rise -8.
Okay.
So that's fall 8, run 3.
Okay, so
Fall 8.
1,
So what I did was 5,
over.
6, 7, 8, and then over 3.
I still don't see why you got, over 3. But
Yeah,
why negative
down 8,
3?
over 3. Say again?
Why, because 3 is x, and -3,
Is y. Yeah, so it's always x first, y second. So where's that point? Over 3, down 3.
down.
Yes. How do I name points? I mean, I'm trying to guess what the issue is. We name points based on where they are related to the origin, right?
Yeah.
That's 0, 0. So that point is 3 over and
That's the
down
x,
3.
And down 3.
So that's why it's the point 3, -3.
Okay.
I like it. Okay. So last thing. See what you guys think about this. Still thinking about this equation. Find the equation of the line that goes through 0, -4, and 2, 2. Sure, why not? I like it. I would. So you're like, how the shit, well, what equation of a line do we have? In general, what's our equation of a line that we know?
Y equals mx.
Y equals mx plus b. What two things does that equation need so that it becomes the equation for a line? What two pieces of information do I have to put in there? I have to put in there the slope and the y piece, the y-intercept, right? Do we know either one of those two things already for this problem? We do. There's one thing I know for sure, and the other one I have to calculate. What is this? 0, -4. That is the y-intercept. So what's b? -4. See? Do you guys see?
Why
Maybe.
you say B? Why you say Y?
Say it one more time.
It's Y, -4 is Y.
It's the y piece of the y-intercept. How do I know that's the y-intercept? Because x is 0.
Yes.
Okay, and what's the b represent? In general, it always represents the y piece of the y-intercept. So every line, here we go, every line has an equation, right? The equation of any line, the number where b is, will be that line's y-intercept. It just will be. It has to be, because when I make x 0, I get frickin' b. So what number am I going to put there? -4. So I know what b is. b B is -4, check. So what do I still need to figure out? Slope. I still need to figure out what the hell M is. Once I get those two things, I know the equation. I just throw those in and I'm done. So how do I get the slope?
You plug it in to x and it to y.
Yeah, what's the formula? M equals, some of us had it flipped the wrong way. I'll get it started. Y2 minus, maybe I'll keep going, Y1 over X2 minus X1. You had to do that on the test. So I can do 2 minus -4. Some of us had trouble with this. Two negatives make a positive, right? 2 minus -4, and then over 2 minus 0. So it's always the y's on top. What's 2 minus -4? 6 over 2 is 3. So what's the equation of this line? It's going to be y equals, what's m? 3. X, and what's b? -4. How do you check it? Well, if I plug a 2 in, do I get a 2 out? 3 times 2 is 6 minus 4 is? Check. Maybe? No? So that's the connection. That problem is the reverse of the problems we did before. I was given an equation with the other problems. And then I figured out the slope and the y-intercept. If they want me to give them an equation, I have to first figure out the slope and the y-intercept. And then I throw them in the right place. It has to work both ways. If they give me an equation, I can see the slope and the y-intercept. If they want an equation, I can put in the slope and the y-intercept. Bam. It's got to work both ways. This semester's been weird. I get no reactions. I can't tell how anything is landing.
The slope can be a whole number?
Of course it can. Yes. We would just write it, just to make it make full sense, we could put it over 1. There's always that understood over 1. I do get sometimes people rise 3 and they don't run at all, and then they say, well, there's nothing there. Well, no, there's an understood 1 that only shows up when we need it. To be really honest, it's just us being lazy. It really should be always written, but we're like, nah, let's just tell everybody it's there. Maybe. Okay, let's say that's enough. Maybe? Maybe, is that enough? Okay. I like, some of you guys are like, you're the teacher. All right, it's enough. That's plenty for today. So we'll get back into this tomorrow. We'll have the whole time to really get deeper into this. We just did section 4 or 5 basically. Yeah. So we're just keeping our march through chapter 4. All right.